Hello there, welcome to this show today on Darlington Gospel. And if you're new to this channel, you're welcome. If you're a returning viewer, you're also welcome. We're very happy to see you here today. So in today's tutorial, I want to actually teach you some important concepts that you need to know about the blockchain space, as you go deep and as you apply for a job. Let's say, for example, you want to go for an interview, you need to know some certain things, at the back of your hands or at the front of your hands. Okay, so these are some questions that you may not come across when you are building, directly on the blockchain, because you don't need to answer too many terminologies when you're building. But when you are on the interview process, they kind of, dump a whole lot of questions on you that you need to answer, and your explanation of this concept, kind of have a determining factor if you're going to land that job or not. So I'm going to start up a series to help us bring to light various concept terminologies of the blockchain space that you as a developer need to have understanding about, so that as you proceed in your job hunt, it will be very easy for you to crush those interviews. So this is interview questions and answer for the blockchain space, episode 1. If you haven't subscribed to this channel already, please hit that like and subscribe button, hit the notification bell so you won't miss out any important, release of tutorials on this channel. We've actually expanded our space a lot of recent, so we've offered various tutorials in different blockchain languages, not just Solidity alone, but we've gone ahead and expanded our ecosystem to touch different blockchain networks, because in the real world, you're going to need, to expand beyond, Ethereum as well. So now with that said, let us jump into this tutorial for today. So the first question I want to tackle today is called, what are the recent improvements in blockchain technology? So if they ask you that question, what are the recent improvements in blockchain technology? How are you going to address that? What are you going to say? So these are some areas that you should study and get some light on. And these areas that I'm about to mention highlight the recent improvements and development that have happened to the blockchain space. Number 1, layer 2 scaling solution. So layer 2 scaling solution, the reason why we have layer 2 is to address the drawbacks of the layer 1. The layer 1 system, such as Ethereum, I'm going to use Ethereum for this use case, okay? So Ethereum is cool, one of the OG guys that brought decentralized application into the picture, right? So, but Ethereum had this major issue that has to do with scalability. Ethereum transaction rate was very poor. It processes up to 15 transactions, per second. I think 10 to 15 transactions per second, which is really slow if the entire world are going to be using that particular infrastructure. So it can really become very slow and increasing transaction fee to an insane amount. Okay, so it was not very scalable. All right, it was secure, it was great, it was not scalable. Okay, and transaction fee were very high, and also it consumed a whole lot of electricity, just like with Bitcoin. It was using proof of work, and that actually impacted a lot in the capacity of power or energy that is being consumed to process transactions per second, because of the nature of the consensus model that Ethereum was using then. No, but with Ethereum 2.0, it kind of changes. Okay, so, and even at that, it's still around 15 to 20 transactions per second, which is not good, even though I think there's the final stage of this Ethereum upgrade involves sharding, and I think probably they have already implemented this by now, but I think sharding was the last phase of these upgrades that Ethereum was doing to facilitate the transaction execution process. Okay, but that is still not enough. That's why Ethereum does have a lot of layer 2 solutions. So the layer 2 solutions, they come into the picture to resolve these major problems, which involves transaction fee, so it will result in reducing the transaction fee. Okay. Secondly, it also was built to address the scaling issue, the scalability issue, so that more transactions can be processed per second, just like now layer 2 solutions such as Polygon can process up to 7,000 transactions per second. Meanwhile, other solutions, can process between that kind of 500 to 4,000, transaction per second. I'm going to discuss about that. Examples of layer 2 solutions that actually does that very well is Optimistic Rollups. So rollups are basically, software improvement, upgrades that happen on the chain. Okay, so one of it is Optimistic Rollups, which involves some certain blockchain that implemented features that enabled the base layer 1 solution, which is Ethereum, to be a lot faster. So such as Optimism is one of these blockchain, Arbitrum and Metis. And then there's another one called ZK-Rollups, which involves ZK Sync, Loopring, and Stacknet. All right, so the major difference between these two kinds of improvement in terms of layer 2 solution and scaling the layer 1 network is in the validation process, okay, the transaction validation process. Since the both of them employ a strategy of batch processing of transaction, because they don't process transaction one after the other, they bundle transaction together and process it, is because the Optimistic Rollup relies on the validations that have already happened in the layer 2 blockchain, to merge it into the layer 1 blockchain. I don't know if you get this, but it doesn't go about doing its own special, validation on itself. So, for example, if Optimism is pushing up some transaction into the space, it's relying on the trustworthiness of Optimism to have validated those transactions accurately, so that when it's coming into Ethereum, when it's being merged in this layer 1 solution, it will no longer need to perform a secondary check. Although there is some, scanning process to ensure that the transaction that are being added has already been validated. You just have to scan it, but they don't perform a validation process again. Meanwhile, the ZK Rollup, which actually utilizes a technology known as a zero knowledge proof, okay? It has to still perform a validation under the hood on those transactions that are happening. Now, the difference between the two is that why Optimistic Rollup improvement to the layer 1 blockchain space is it takes a lot of time, you understand? So something like 1 week for a batch of data to be, dropped or processed under the layer 1. Meanwhile, the ZK Rollups, they happen more, faster, you understand, like more instant than that. So it could happen within a day, within a day process, because this process of revalidating all those transactions that happen concurrently, they don't have to wait for weeks, you understand? So the process is faster. Now, the problem is that this ZK rollup means, it's going to utilize a lot more, energy to be processing, because it has to now run another set of validation process again, and all that. It's basically a consensus model. So these are the difference between Optimistic Rollups, an upgrade that was done in the layer 1, which is the Ethereum, and then ZK Rollups, okay? ZK Rollups, they utilized zero knowledge proof. So in answering this same question, what are the improvements that have been recently done in the blockchain space, is to mention about consensus model. All right, consensus model used to be proof of work, which consumed a whole lot of energy, but now a lot of increased changes have been done in this space. And I'm using Ethereum, for example, in this particular explanation, because there is a whole lot of blockchain that use specific different, similar, different, consensus model, and most of them are, have shifted into models or mechanisms that are energy efficient. But before I talk about that, I need to let you know what consensus model is, or consensus mechanism. It basically is the algorithm, okay, that determines how computers or nodes in a blockchain network agree on the validity of a data. The new consensus mechanisms that are being rolled up now, improved upon, causes the blockchain to utilize less energy than it used to. For example, Ethereum, when it was using proof of work, was consuming quite a whole lot of energy, just like with Bitcoin. But now it uses, it has reduced its energy consumption in this new consensus mechanism called proof of stake. It's now used 95% of less energy than it used to use. So this is another improvement that is done, thereby causing eco-friendly situation, for the, it's not cool for the entire blockchain to use that amount of energy. In fact, it was so bad that energies that most countries don't consume, you understand, that was what Bitcoin, for example, Bitcoin consumes a whole lot of energy that can be delegated to an entire country. That is so crazy. Okay, so that is one thing that you must mention about the improvement that have been done in this space. Lastly, the improvements that have been done recently on the blockchain space is zero knowledge proof. This is a big upgrade because the idea of blockchain is to provide, confidentiality, privacy, and security. And if a blockchain is not actually providing those sort of services, it's not really, great blockchain to say, especially if it is public. So because blockchain brought about the era where we, are migrating or transitioning from the traditional financial systems into a more, peer-to-peer, decentralized, privacy-oriented blockchain, which is fast, considering the fact that you don't have to wait days before you receive money if you're transacting money. If it is in fiat ecosystem, for example, if you're living in America and then you want to send money to Africa, it kind of takes days in the fiat-based system, the traditional system. But with blockchain, it actually happens instantaneously, as quick as possible, depending on the speed of that blockchain and all that. So zero knowledge proof adds to the privacy, benefits of the blockchain. It increases the security that the blockchain currently does possess. And although not every blockchain network have implemented this, but a lot of blockchain are shifting into zero knowledge, proof. So what is zero knowledge proof? I would like to describe it for you in this little example. So zero knowledge proof is a security validation system that enables a party, let's say party A, to prove to party B that a statement is true without spilling the beans. So if I can tell you that something is true without me giving you the information, secret information that could compromise the security of that, then that is zero knowledge proof. Let me give you an example, okay? Let's say Ashley, okay? Ashley is saying that they are qualified to vote and they want to vote. I want to actually prove that. I want to know if Ashley is 18 years old or older. Without she giving me her birth date, I want to know if Ashley is 18 years old or greater as she has, claimed to be. How do I get this thing without getting her, ID card or anything or other information such as she telling me her birthday? Then what you need to do is to employ the zero knowledge proof, which will involve asking Ashley some certain questions, just giving Ashley some certain questions, that she can answer, or certain tasks that she can do, okay, that will demonstrate that she is actually 18 and above without her showing me her ID or telling me her birth date. Now, depending on the platform or the blockchain network and how it was designed, it will, give Ashley some questions or tasks that Ashley must do, and she must complete those tasks. And in completing those tasks, it will be known or verified if she is above 18 or 18 and above or not. Okay, so this is the idea, okay? Okay, there we have it for this first shot at bringing you some interview questions and answer that, and concepts in blockchain that you need to have understanding about, you need to be thinking about, because you may have to explain it, whether it's in an interview situation, or you're doing a public speech. Let's say you're doing a presentation before a bunch of people, you understand? Let's say you're giving a talk in a blockchain conference, or so, that you need to be able to answer this sort of question, because you could be asked this sort of question. So this is the purpose of this particular series. So in the next one, we'll talk about more concepts. Maybe if you have some things that you would like me to explain or research about and bring it to light and add it to my presentation, then you can drop that in the comment section. Other than that, please hit that like and subscribe button and the notification bell, okay? I'm Darlington, and I will see you in the next tutorial.